distinguished guests, respected teachers, professors, my seniors, juniors, participants, and all the audience, a very good morning to all of you. I am Roshna Manandhar, currently working as a tutor and a researcher. Today, my presentation is entitled as Generation of Atmospheric Pressure Dielectric Barrier Discharge (DVD) using Water Electrode. This is my thesis paper supervised by respected Professor Dr. Deepak Prasad Subedi. And here I go. Here is the outline for my today's presentations. Introduction. As plasma can be classified in various ways such as based on temperature, pressure inside the reactor and electric signal. On the basis of pressures, plasma can be divided into two groups, atmospheric pressure plasma and low pressure plasma. Well, everybody is well known about low pressure plasma as it is extremely used nowadays. For example, in semiconductor industry for computer chips manufacturing, but due to some disadvantage as it requires expensive vacuum chamber to generate the plasma. Therefore, we generate plasma at atmospheric pressures. Here are some characteristics of non-thermal plasma. Now, moving to the next slide, that is, here are some advantages, disadvantages, and applications of atmospheric pressure plasma. Nowadays, different research center and university are interested in the field of atmospheric pressure plasma due to its number of advantages over low pressure plasma, as it is cost effective, it is easy to handle and operate than low pressure plasma. Similarly, due to their broad range of applications such as plasma sterilization, cell treatment, polymer treatment, wastewater treatment, we consider atmospheric pressure plasma as or interested by the different research center and university. On the other hand, there are some disadvantages like difficulty of sustaining a glow discharge. It's difficult to form a uniform plasma, required high voltage. Now here is dielectric barrier discharge DVD. Here DVD or dielectric barrier discharge is also called silent discharge, where the discharge is generated between two electrodes, which at least one is covered by dielectric materials like glass, polymer or ceramic using high voltage AC power supply with a frequency in the range of kilohertz. And here inner gases like helium or argon is required to produce a stable plasma. Now here is my experimental design. Okay, this is the experimental design for this experiment, and this is the typical experimental setup used for this experiment. Here the discharge was generated using a high voltage of 0 to 20 kilovolt power supply operating at 10 to 30 kilohertz with water as one of the electrode, and use borosilicate glass as a dielectric barrier of 2.5 millimeter thickness. The discharge dose obtained was investigated by image analysis and optical emission spectroscopy. And these are some early works in DVD with transparent electrodes using TCO, transparent conducting oxide. And similarly, the early works in DVD with water electrodes. Here, Sao et al. Has reported that the discharge current and emission intensity are smaller in the case of water electrodes, which also resulted in a lower rotational temperature when compared with the metal electrodes. The use of water electrodes can improve the required conditions of obtaining a homogeneous discharge. In addition, it was found that the discharge starts from the center and expand radially outward the discharge and cover the entire electrode surface step by step. Now, here we can see the images of discharge at particular frequency, that is 27 kilohertz using water electrode. And we can see that here the number of micro discharges increases with increases in applied voltage. Now, here the metal electrodes versus metal water electrodes. DVD with metal electrodes, we can check just a side view of generated discharge, but in DVD with water and metal electrode, we can view front view of discharge, which helps to investigate the uniformity of micro discharge. Now move to the results. Okay, these are the emission spectra of DVD using 1% HNO3 solution applied at different voltage. Similarly, emission spectra of DVD using 5% HNO3 solution applied at different voltage. This is the emission spectra of DVD using 10% HNO3 solution applied at different voltage. Now moving to the calculations. Here, the calculation of electron temperatures is done in discharge with 1% concentrated solution applied at 1 kilovolt, and for all the calculation of electron temperatures applied at different concentrated solutions applied at different voltage have done, and the measurement of electron temperature is done by line intensity ratio method, where R is the ratio of intensity of two lines, I is the intensity of spectral lines, Aij is the transition probability of the transition I to J, and Gi with the statistical weight of upper level, lambda with the wavelength of radiation, Ei be the energy of upper level, K be the Boltzmann constant, Te be the electron temperature. Here the values of lambda and I, wavelength of radiation and intensity are obtained from the observations, and the values of transition probability of transitions, statistical weight of upper level, and energy of upper levels are obtained from NIST atomic spectra database. And here are the values of Aij, Gi, and Ei, and by substituting this value in the above equations, we obtain intensity ratio of 44.34 by taking electron temperatures 0.9 electron volt. Similarly, the other values of Te and their corresponding intensity ratio are listed in the given table. And here the given table shows the intensity values corresponding to different wavelength for nitrogen second and nitrogen third lines, and from the observations of table we can get intensity ratio is about 14.68, which corresponding to electron temperature 1.40 electron volt. And this is the spectra of atmospheric pressure dielectric barrier discharge in the range of 180 nanometer to 700 nanometer at 1 kilovolt having 1% HNO3 solution. And the next graph shows about the intensity ratio as a function of electron temperature. Here are the corresponding values of electron temperatures for 1%, 5%, and 10% concentrated solutions we got from the experimental process. And these are the spectra of atmospheric pressure, DVD, and the plot of intensity ratio as a function of electron temperature for all the concentrated solution applied at different voltage. And this graph is plotted between the electron temperature and applied voltage, and here we can observe that the electron temperature decreased slightly with an increase in applied voltage. Although this result is unlikely, it has a good agreement with the result reported by validity of electron temperature measurement by using Boltzmann plot method in radio frequency inductive discharge in the atmospheric pressure range. Now, moving to the second part, that is applications of DVD for surface treatment of PET polymer. Now, here is hydrophobic versus hydrophilic surface. We know that if the contact angle is greater than 90 degrees, we consider it as a hydrophobic surface in which the adhesiveness and wettability is very poor, whereas the solid surface free energy is low. Similarly, if the contact angle is less than 90 degrees, we consider it as a hydrophilic surface in which adhesiveness and wettability is very good and solid surface free energy is very high in it. And here are some methods of surface modification. And these are the physical property of PET sample, polyethylene tetraphthalate, and the PET samples was received from Goodfellow, and these are the conditions of plasma treatment. And here the figure shows the polymer sample under the treatment. And for surface characterizations, so here the surface characterizations done by two methods, contact angle measurement and surface energy measurement. For the contact angle of polymer liquid surface is measured by the method static Seychelles drop method using a goniometer. We can see here goniometer in our screen, and this technique has been used widely to measure the contact angle of liquid with solid. And for surface energy measurement, here the surface free energy can be calculated in terms of polar and dispersion components with the use of Fock equations. And here in the given figure shows the images of water drops on PET polymers treated by DVD at atmospheric pressure, and it is seen that there is change in the static water contact angle on polymer, and this is the effect of treatment time on wettability of PET sample. Here the graph shows the variations of contact angle as a function of treatment time in the discharge. Similarly, variation surface energy as a function of treatment time in the discharge. Here we can see that there is a rapid decrease in water contact angle take place within the treatment time up to 20 seconds, which shows the strong increase in wettability in polymer. And after 20 seconds, we can see that there is no any significant change in the contact angle, which means the saturation of plasma effect occur, and the reduction in contact angle might be due to the change in surface roughness. Similarly, the increase in surface energy was also significant in the first few seconds, but afterward it increased slightly and achieved the saturation thereafter. Now the next slide shows about the variations of surface free energy with treatment time for PET sample. Here the surface energy of untreated PET was found to be 34.9 millijoule per square meter. It is seen that the surface energy significantly increases for a few seconds of treatment time, become maximum to about 73.9 millijoules per square meter after 20 seconds, and the similar trend is also observed for polar components, but for a dispersive component we can see it decreases initially and remains almost constant throughout the time. So it shows that this component does not have any contribution to increase the wettability of PET surface. And now this is the last graph of my presentations, and here the given graph shows the variations of polar and total energy components with treatment time for PET polymers. Here in PET treated films, the ratio between these two parameters is found to increase for a short treatment time, indicating that there is a change in the physical and chemical change for few seconds. And finally, we can say that the change in total energy is due to polar components only. And lastly, the conclusions, and these are my conclusions. Thank you.